Hi everyone. Let's go through a demonstration of how to cast shadows in orthographic views. In this example, we're going to take a look at the plan and elevation of a simple cube. All right, so start with the box. My first step is to decide which direction and at which angle do I want the light to come from. And so I've decided I want it to come from above and to the left and to the rear of the viewer, or you can also say this is a frontal light source because it's in front of the object, in this case our cube, right? So knowing that, in the plan view, the light's going to come this direction. And I've decided that the light is falling at an angle of 45 degrees. So I'm going to take my 45-degree triangle and cast some guidelines from the important points of our object. Now, I'm not casting it from this one simply because that shadow is going to fall internally in this solid cube. If it was an open box or a glass box, I would be more interested in that point. Right, so the shadow is going to fall this way, but how far? Now, you can actually calculate that using geometry and measure it out, but there's an easier way, and that's why we have the elevation drawn right here. In this elevation view, the light is coming in this direction. All right, it's coming in at this 45-degree angle. So we can take our triangle and cast shadow from our important points. All right, cast a guideline, and realize that the shadow is going to be falling on this piece of ground. You can't see it in the elevation view, but in 3 dimensions it would be there. This gives us this important point right here. All right, and that's where the shadow hits the ground, and that will we'll be able to take that measurement and transfer it vertically to our plan view because we have them aligned and to the same scale. Right, and realize that our shadow will stop right here. So here's our important point, right? Right where it crosses right here is an important point, and we can transfer that horizontally over here, right? In the end, our shadow is going to follow this, this outline, right? And let me shade it in for a demonstration here. And that's how to cast shadow in plan and elevation view. In our last example, we saw how to cast a shadow from a cube sitting on a ground plane. But what if there's something in the way? In this example, we're going to take a look at the same cube, but this time it's sitting in front of a wall. In plan view, we see the wall sitting behind our cube right here. In elevation view, here's our cube and the wall is behind it. Let's start out just like we did with the last example by determining which way we want the light to fall. We're going to stick with our same plan. It's going to come in from 45 degrees from up, left, and behind the viewer. All right. So in our plan view, that means that our shadow is going to be casting this direction. In elevation view, it's going this way and back down into the drawing. All right. Let's look at that plan view and start out, just like we did, by picking important points and casting a 45-degree guideline. We'll do the same thing in the elevation view. Again, finding this important point and transferring it up towards our plan view. So the plan shadow in this case is pretty easy to figure out. All right, it's going to be right here. Hit the wall and stop. All right, this way, come back out, down that way. All right. But what about the elevation view? We're actually going to see the parts of the shadow that hit the wall. What would that look like in 3 dimensions? Let's take a look. We would see this shadow on the ground go something like this, and then go straight in towards that wall. Right? It's going to go up, and then this line of the cube is going to cast a horizontal line on the wall, right? And then we won't see it, but tucked back in here will be a vertical line right there. Okay, so in 3 dimensions, that's what we're going to look. That's what our shadow is going to look like. So how do we do that on our elevation? Let's take a look at this piece on the wall and note this important point right here. We'll transfer that information down to the elevation and find this important point. Right? Take that over horizontally, and you'll find that the shadow is this piece right here. The rest of it is hidden behind our cube. So this is what our example of a cube casting a shadow falling on a wall behind it looks like.